Hello everyone, our today's question is 2 benzylic hydrogen Ha and Hb in compound 1 and 2R. Here we have this compound 1 and compound 2. Here this is Ha and Hb. This Ha and Hb are homomorphic ligand. What is homomorphic ligand? The group or the atom which are identical when they are considered separately, but when they are considered with respect to any molecule, then they are different. So they are here Ha and Hb. When this hydrogen, we consider this hydrogen separately, then they are identical. But if we consider this Ha and Hb with respect to this group, then they are different. So they are homomorphic ligand. Now we have to check the topicity of this homomorphic ligand. So there are two methods to check this topicity. First is substitution method and the second is symmetry method. So let's check the topicity of this homomorphic ligand by symmetry method. So first of all, let's convert this molecule in their chair form. So here there are two methyl groups are and on wedge position. So we take this two methyl group on equatorial position, and here one is on wedge and one is on dash position. So we take this methyl group at equatorial and this methyl group at axial position. Now first of all, to check the topicity, we have to consider the C2 axis. So in C2 axis, if we rotate this Ha and Hb in 180 degree, then this group is change its position. So we can say that the C2 axis is absent. So if the C2 axis is present, then these two homomorphic ligands are called homotopic. But here the C2 axis is absent. So Ha and Hb are heterotopic. Now there are two types of heterotopic, enantiotopic and diastereotopic. So to check these two types, we have to consider the plane which is bisect this Ha and Hb. So this is the plane which bisect the Ha and Hb, and this plane we can see that the above the plane and the below the plane groups are identical to each other. So we can say that they are mirror image, and so if this plane, the groups are mirror image to each other, then they are enantiotopic. So here this Ha and Hb are enantiotopic. Now in this our second compound, there is also C2 is absent, so these are heterotopic. Now here if we pass the plane in between the Ha and Hb, then the group which is above and the below the plane, they are not mirror image of each other, because this CH3 group of this position is at equatorial position, and in this position this CH3 group is at axial position. So they are not mirror image. So here our homomorphic ligand are diastereotopic. Now our second method is substitution method. So in substitution method, we have to replace this Ha and Hb by any test group, the test group which is not present in this molecule. So here let's consider the test group Z. Now first of all, we replace Ha by Z, and in second we replace Hb by Z. So we get these two compound. Now let's check their stereochemistry. See here, these both compound are mirror image of each other and they are non-superimposable. So these two compounds are enantiomer. So we can say that these two homomorphic ligand Ha and Hb are enantiotopic. Now in our second compound, if we replace Ha and Hb by this test group Z, and we get these two compound. Now if we check this compound stereochemistry, the both compounds are not mirror image of each other, so they call diastereomer. So these Ha and Hb homomorphic ligand are called diastereotopic. So our correct answer is B. The homomorphic ligand Ha and Hb in compound 1 is enantiotopic, and in compound 2 they are diastereotopic.